if I have traffic on my network, then we'll say we want to protect it from being intercepted. So we want to make sure no one along the way can read what we're doing. So we want to conceal it. All right? The most basic, or wait, oh, there's a few. We'll talk about, there's various techniques, but what we want to do, so we'll say here, various techniques obscure traffic, but we also worry about what's called a man-in-the-middle attack. And here's how man-in-the-middle works. So say here I'm Alice, and I want to talk to Bob. Okay, so I got my computer here, and I want to talk to Bob. We'll say Bob is the server. Normally I would expect I would just send a request, and I would get back a response, right? Okay, and I would expect, right, I am talking to Bob. So that's a big assumption. But what happens is, I forget what my C is, Carl. So Carl might be in the middle though. And if Carl can intercept the request and relay the request to Bob, get the response back, and we saw this, right, with our NAT. That it is very possible for this to be relayed sort of like this. That's awesome, right? So this is the man in the middle. Okay? Carl is now the man in the middle, and you know, he takes Alice's requests and then sends those to Bob, and when the response is back, sends them over to Alice. And what we worry about, and this has come up very big in the Heartbleed problem, that is, if someone has the certificate, so if Carl has Bob's certificate, the certificate is what Alice used to make sure that's Bob. So one of the issues of the Heartbleed bug is, you know, Carl was over here and they attacked with the Heartbleed and got Bob's key. And now Carl can present Alice with Bob's key and pretend to be Bob. So that's awesome. I guess my point here is what I'm going to tell you doesn't protect you against this. You worry about this too. Think about if I'm at a like at a coffee shop on their Wi-Fi network. All my traffic goes through the coffee shop's router. And it's a potential that someone could hack that router and then pretend to be Facebook, pretend to be whoever that you're getting stuff from, and then getting your stuff. That stuff's fun. All right. The most basic security is a cipher. I don't know why they use cipher, because cipher actually means a lone person. That's okay. A cipher. A cipher, so this is a technique that takes plain text and then it converts it to what they call ciphertext. And if you all did that encryption exercise, you just did that, right? For that hands-on, you created a cipher, so your technique for obscuring the text, and then I told you to take that long message, 50 words, and then you converted it to ciphertext and you gave it to me, and that's what's posted on the website. Okay? So that's a cipher, right? And what normally happens with a cipher is you need the key. We'll just put here. You need to know, we'll put first the technique and the key to decrypt it. Okay? So if I'm trying to intercept someone that has sent some ciphertext, if I know the technique they used, and I know the key they used, and I'll tell you the key in just a second, then I can decrypt the message. So here's an example. If my cipher is, if I add 1 to the letter, that would be like A is going to be B, B is going to be C. You'll see that? So my cipher is add 1 to the letters. The technique is this adding to the letter. Okay? The 1 is the key. Are we good here? So if I did a key of 2, what would I do if I used the same technique and my key was 2? What would A be? It would be C, right? Because now it's 2. So I could do 3 and then it would be D. You guys following me here? So the key here is that how many letters? The technique is the adding to the letters. So I reverse using the same key. Okay? So a cipher B equals A, C equals B. So if I'm going to put hello, I'm going to get I, F, M, M, P, right? And then here, when I reverse it, I just subtract it out. So I take the I, F, M, M, P, I subtract 1. Oops, this is the plus 1. Here's the minus 1. And I end up with hello coming out. Are we good here? So I have a key, or a technique and a key. The technique is normally public. Okay? The key is secret. Okay? So that's just the normal way it happens. So on the internet, everybody knows what they use for their techniques. The thing that they keep secret is the key. And I'll just note one other thing. If you use the same key, we call this symmetric key. Okay? So this technique I just showed you is symmetric key, and we'll talk about, there's another way to do this. Right? So we keep the key secret. Okay? So if I'm circulating notes in class, the teacher's going to get the note and they'll see a bunch of funny letters, but what it'll be is the teacher won't know what the key is. Right? They won't know they need to add 1. You following me here? So how many options do I have if I'm doing letters of the alphabet, 26 letters of the alphabet? How many possible keys are there here? I can go +1, +2. How far can I go? I can't get to 26 because then there's only 13 because it switches directions. Does that make sense? Anyway, but that's all right. It is kind of like 26. But there's not very many possibilities of my key if I'm using this technique. Y'all can see that? What we want is the longest key possible. By the way, those of you that are working on hacking, I've only got 2 so far, and that's not very many. Like out of all the stuff posted, what?
On the Cyphers assignment?
On the Cypher assignment, I've only had 2 people that have cracked all 4 of their codes.
Oh, I didn't even see anything posted.
Oh, it's up, yeah.
Oh.
Cypher, yeah, they're up. 5 points each. There are, there's 10 up there, and I'd probably say 8 of them are like, you just do, the little thing I sent you, it tells you how to do it, and you just do that, and you can totally hack them. It's easy. So, You still got until...
And I forgot to post on.
Oh, okay. Oh, that's okay. If you didn't post, you don't get the 10, but you can still decode for this. And it's fun. It's so much fun. I'm always wanting to go. Like, everyone's like, oh, did you see my technique? How good is it? And I'm like, I don't ever look at them because sometimes I want to crack them. All right, long keys are critical. So, I'll just show you how it works. So you saw my hello, right? Let's do this. The quick brown fox. Okay. If I'm using the key that's the key 1, right? It's going to be T goes to T U I F. Should we encrypt the spaces? Oh, we'll just leave them. Q goes to R, U goes to V, I goes to J. See if I can remember these. By the way, I got an email today that was like, hey, there's a typo in somebody's message. And it's because this is a big pain, right? B goes to C. Y'all see me. I'm like I'm the god of binary conversion, and even on these, I'm like, what? What comes after R again? R goes to S, O, P, W, X, N, O, F, G, O, P, X, Y. Okay? So there's my encrypted key length is 1. Right? Now we can see that's memorizable, right? Now what if I wanted a key length of 2? Let's do one of 5. Okay? And the key of 5 I'm going to choose is my last name, H-A-I-N-E-S. Oops, that's 6, sorry. Okay? What I'm going to do, I don't want to do this one. I'll just do a short one. Key equals, let's go with 3. Okay? And we'll put cat. Okay? Cat is the 3rd letter of the alphabet. A is the first. What's T? Okay, we're going to change it to cab. It's 3, 1, and 2. Okay? Now, what I can do now is I put my 3, 1, and 2 up here. Now I see T goes up 3. T-U-V-W. H goes up 1. E goes to F, G. Q, I still need 3, 1. Well, I can do the spaces now. This gets fun. So we wrap around. So a space goes to A, B, C. 1, 2. Q goes to R. U goes to U, V, W. 3, 1, 2 again. C goes to D, E, F. You guys see where I'm going with this? K goes to L. Am I on space now? This space turns into A, B. And you all see that? Now, those of you that are decrypting, you'll see that what's happened here is if I go to count the frequency of the words, I reset the count for every time that key changes. Up here, I can go through and I can count, how many times does F appear? Why do I like to look at which one is going to, I see that F appears most in the message. Why is that important? Because E is the most used letter in the English language. So if I count F and I find out F is by far the most used in this message, then I can see, oh, I bet F stands for E. You following me here? But if I look down here and I say, okay, if I count, for example, the number of G's, the number of G's that come up, it'll come up from 3 different ways, right? Sometimes it'll be an E converted to a G, sometimes it'll be an F converted to a G, and sometimes it'll be a D converted to a G. And so it's divided by 3 basically, and if I do my word count, my distribution will be a lot flatter. And you basically can't decode it this way, or you can't hack it this way, or crack it. Now, do y'all believe me, right? So I decided my key was cab, because I was that lazy, sorry. It's 3 long, and right away, I've upped. It's basically gone from being fairly easy to crack to basically impossible to crack, at least by a teacher that gets a hold of the message. Y'all seeing that? Could you still memorize this? Yeah, it's totally memorizable, isn't it? So all I got to do to my friend is say, okay, today's key is cab, and they have to remember it, and then they'll be able to do that way, okay? So that's long keys are critical. And so now if you see, in the old days of the internet, we used to have 40-bit keys. Then we had 128-bit, which is sort of common now. But now it's more, I don't know, the cool people are using 256, or you even see people with higher. They'll be 512 or 1024-bit, and those are the paranoid. So if you're really paranoid, that's where you are. But really a 40-bit key, and all it is the computer has 40 bits and it's just flipping the ones and zeros, right? A 40-bit key was actually pretty easy to crack with a computer going through, and what it's doing is it guesses what the keys are. So it can cycle through all the possible combinations of 40 bits, cycle them through on your message until it finds something that works. 128 bits, with every bit you add, it doubles the time. You guys see that? So when you went from 40 to 128 bits, I'm not going to tell you how much longer it took, but it took a lot longer. So 128-bit, we're a long ways from having computers out there that are ready to hack those. 256 is kind of the new standard, which would be, you know, how many, I don't know, it's to the 128. It's way more than double, I mean, doubled and doubled and doubled here. So that's cool. Long keys are critical.